Students, today we are going to start new chapter that is known as coordinate geometry. Okay, and before we start this chapter, you have to know few things which you have already learned in class 9. That is, we have done in graph that there used to be a axis. Yes, two type of axis like this, one vertical and one horizontal axis. Yes, one vertical axis is known as y-axis and horizontal axis is known as x-axis. You are familiar with these things. So we know that when you find out any point, yes, in this x-axis towards the x-axis, then that is known as x coordinate. Okay, and towards the y-axis, if you are plotting any point, that is y coordinate. So x coordinate is known as abscissa. You all know these things, abscissa. And y coordinate is known as ordinate. Okay, so these things we know. Yes, and there used to be 2 points, that is coordinate, that is x coordinate and y coordinate. Like in alphabet, x comes first, so x, right, we used to write in first, then y. So this both together is known as coordinate. Okay, and individually it's known as abscissa and this is known as ordinate. So we can find out, like it is written in the book, the coordinate of the point on the x-axis are of the form x0. That means any point lies on the x-axis, this axis. Okay, in this axis, whatever of point we used to be plotted, like 1, 2, 3, 4, 5. If I am giving you 5, you'll put over here, yes, 5. Then if 0, then 0 we can't move, so here only. So it's 5, 0. So what type of point we are getting? It's like x0. So x0, this type of point we used to plot or we used to get in x-axis, not in quadrant. I'm not talking about the quadrant. Okay, so in x-axis this type of point used to lie, where y used to be 0. Similarly in y-axis, what type of point we will get? We will have to start from 0. So 0, then 1, 2, 3, 4, how much you want. So here let's say 0, 4. Okay, that means we are getting 0, y. This is very important concept. So in x-axis we are getting the point of the type x0. That means y coordinate will be 0, and in case of y-axis we will get x coordinate 0. So this concept you need in this chapter, and after that you need distance formula. Okay, that means if I need to find the distance between any 2 points, like it is shown in your book, like here, if I need to find the distance between these 2 points. Okay, so not only distance formula, you need to know the Pythagoras theorem. Pythagoras theorem is also very important in this chapter. Okay, so we are familiar with the Pythagoras theorem. So Pythagoras theorem is very simple. Pythagoras theorem says that hypotenuse square is equals to perpendicular square plus base square. So this is Pythagoras theorem, and how to apply this Pythagoras theorem you will understand when I'll teach you the exercise. Okay, so next is distance formula, which I was talking about. Okay, so distance formula is nothing, it's very simple. It's given in your book only in page number 158, so you can see. Okay, so what is this PQ and all, what is this x2, x1? Let's have a look. So from here you can understand. Like I told you, you have to find the distance between this P and Q. Okay, so PQ, that is PQ. So distance between PQ is what? It's nothing. It's x2 minus x1 whole square plus y2 minus y1 whole square, under root. Okay, under root x2 minus x1 whole square plus y2 minus y1 whole square. So this is distance formula, and this is very important in this exercise. We are going to do this first exercise, and in this exercise you need this formula only. So you can write this formula in your copies first. Okay, so let's start the exercise now. So In this exercise 7.1, page number 161, first question is find the distance between the following pair of points. So it's very simple, okay? So you have to find out the distance between the pair of points. So points are already given, okay? So question number 1 is 2, 3 and 4, 1, and we need to find the distance between these two, okay? So whenever you are finding the distance, you can give name. So let this is A, 2, 3, and this is B, 4, 1, okay? So distance between AB, we have to find distance between AB. Yes, so what we will do, using distance formula, we get, so what is distance formula? AB is equals to, we have already given the name, so x2 minus x1 whole square plus y2 minus y1 whole square. So you can take anyone as x2 x1, so x1 y1, let's say this is x2 y2, okay? You can write these things with pencil and later on you can rub this. So let's put the value. So x2 is our 4, x1 is our 2 whole square plus y2. Be careful with the sign, sometime you will get negative sign, that time you have to be careful, okay? This time no negative sign, so it's quite simple. Now open the bracket, follow the rule, 4 minus 2, 2 square, this 1 minus 3 minus 2 whole square, use bracket, then 4, this minus square, minus sign 2 times, positive 2 square 4, so it's under root 8. So under root 8 means 2 into 2 into 2, so because of this 2, 1 2 will come out, under root 2 unit. Length we are finding, so unit. So this is the procedure to find out the distance, okay? I hope you are understanding, and this is not so tough, just one formula, okay? Distance formula is there to solve this, then you will get the answer. Now you can try question number 2 and 3, and as well as question number 2 also you can do, okay? And what about question number 3? Determine if the points this and this are collinear, okay? So what are the conditions to find out the points are collinear? So it's again very simple, okay? 3 points used to be given to you. Collinear means co-line, that means lying in the same line like this, 3 points in a straight line. So these 3 points are called collinear. Now you have to check whether the given points are collinear or not. So the given points are 1, 5, 2, 3, minus 2, minus 11. So what we will do here, again we will give name A, B, C, let's say, okay? You have to give name like this. Before the bracket you can put any alphabet, so that will be the name for that points, okay? Coordinates. So what we will do here is, your work is to find first AB, distance between AB, then you have to find BC, then you have to find AC, okay? AB, BC, then AC. Then if you are getting AB plus BC is equals to AC, then you can conclude hence the given points are collinear. So you can write this one, okay? It's nothing, okay? Just you have to find AB. That means how we have find this one, like this, AB, then BC, then CA, otherwise AC, okay? And if you are getting this AB plus BC is equals to AC, then you can conclude hence the given points are collinear. If you are not getting this condition fulfilled, then you can say no, the given points are not collinear, okay? So students, this one is your work. And next is check whether this and these are the vertices of an isosceles triangle. So 3 points are given to you. Now how you can say that isosceles triangle? It's very simple. Isosceles triangle means the triangle with 2 sides equal. So again it's simple, it's like this only. 3 points are given, so you have to find this only, AB, BC, AC, yes. And if you are getting two sides equal, then yes, it is a vertices of isosceles triangle. If you are not getting equal, then no, it's not a isosceles triangle. Okay, listen students, in this chapter you have to know that you have to get the thorough knowledge regarding the figures like parallelogram, square, rectangle, rhombus, because you need it to solve the that next questions. Okay, like isosceles triangle, if you don't know what is isosceles triangle, then you can't solve. Okay, so isosceles triangle means the triangle with two sides equal, so you have to know these things. Okay, so in next video we are going to solve the next question. Till then, just complete your work till here. Thank you.